like the regular algebra problem on the right, what can I factor out from my trig equation? Sine. I'm going to take a sine theta out front. 2 cosine theta minus 1 equals 0. I'm going to draw an arrow here. Don't forget the minus 1. Think about if you multiply back, you have to get what you started with. Distribute. If you forget the 1, it's not going to be the same value. Now let's go back over here on the right-hand side. How did I come up with the answer of 0 on the right? It came from setting this equal to 0, the first factor, and then I would set the second factor equal to 0 and solve to get 1. Please don't use the opposites rule. Okay? Think about solving algebraically. We're going to do the same thing here. So I'm going to take sine theta, set it equal to 0, and then I'm going to do a separate equation which says 2 cosine theta minus 1 equals 0. On my unit circle, notice I've switched to theta so my answer can be in degrees. Where do I have a y value of 0? Theta is equal to what? 0 and 180 degrees. So I have two solutions that came out of that factor, first factor. And now if I solve this, cosine theta is equal to 1/2. That's going to be an x value of what? A little bit of x, correct? Here and here. What are those in degrees? So these 60 and 300. So this equation that I gave you has 4 solutions. 0, 180, 60, and 300. You can leave it like this. I'll be able to find your answers. Any questions on that? It's like we've been building to this moment all along. Can you see it now? The big picture? Guys, do you see it? It's like laid out before you. Here it is. Look at that. That's like our manifesto right there. All right, example 4. We have a problem in example 4. Since you're such algebra superstars, can you tell me what you think the problem is based on what we did in identities? Don't I have different ratios? That's like having different variables, correct? You can't solve an equation, what is a plus b equal to 5, and say a is this, b is this, if that's the only answers. Aren't there tons and tons of answers? Okay. Because of that, we need to be able to have everything in the same trig form. What do you think? What can I replace out in order to change the form of this so it's either all sines or all cosines? Sine squared x is 1 minus cosine squared, correct? I can't use a Pythagorean identity on regular cosine because it's not squared. So the box that I just drew, I'm going to replace with parentheses, and I'm going to say 1 minus cosine squared x, bring down the 2, bring down the cosine x and the 1. I can distribute. And now my transformation is complete, but now I need to bring in old school algebra. Is this a linear or quadratic equation? Quadratic. Quadratics are solved by putting everything on one side equal to 0, correct? Unless you're using the square root method of solving. I don't think that's appropriate here. So I'm going to get negative 2 cosine squared x minus cosine x. I'm going to bring the 1 over. 2 minus 1 is positive 1 equal to 0. Now, personally, do you like to factor when this is negative? No. So the quick fix for this, right, is to multiply everything by negative 1. 2 cosine squared x plus cosine x minus 1 equals 0. Now I'm just going to put a little star over here. Let's forget the cosines a second. 2c squared plus c minus 1 equals 0. This is the pure algebra form of what you're looking at. How would I factor that? I'm going to need a 2 cosine x out front and a single cosine x, so when I multiply I get what I started with. I ultimately need my outer and inner to add to positive 1. So we're looking at this. And what are my 2 equations that I then would need to solve by using each factor? This is my first factor, so the equation is going to be 2 cosine x minus 1 equals what? 0. And then over here I'm going to get cosine x plus 1 equals 0. Where does cosine x equal 1/2? I feel like we just did this. Cosine x equals 1/2 in radians, pi over 3, and 5 pi over 3. Where does cosine x equal -1? At just pi, correct? So this one only has 3 solutions to it. For the next problem, you're going to need your calculator, so pull that one out, please. All right, at quick glance, is example 5 a linear or quadratic equation in its form? Linear. So if I isolate the trig term, I'm going to get tangent theta is equal to 3 over 2. Awesome. Now, here's the tricky part. Is 3 over 2 a unit circle value? No. Okay, so we can actually use our calculator, and what we did with inverses, that unit's now coming into play, in order to solve this. Do you agree? Here's my question before we start, and this is the same one I asked you in an earlier problem. Where is tangent positive looking at a unit circle in one coordinate plane? Where is tangent positive? Quadrant 1 and quadrant 3, correct? Where this is positive, positive, positive. This is negative, negative, positive. I could have either of those scenarios be true. Is there anything that tells me it's going to be definitely one or the other based on this? No. So I should have 2 solutions for this. However, when you go to solve this equation in your calculator, where is tangent inverse defined? It's ascendatan, so it's what quadrants? Where is tangent inverse defined? 1 and 4. So when you put this in your calculator, which quadrant do you think it's going to give you? 1. You have to have the wherewithal to figure out the third, because the calculator won't tell you that. So please put into your calculator the tangent inverse of 3/2, because we're finding the angle theta. We're going to solve for that. What do you get? What'd you get? 56.3 degrees. Okay, that's what comes from your calculator. Make sure your calculator's set in degrees. Okay, so that took care of this black triangle that I'm outlining right now. You remember vertical angles? Yes? Okay, do you agree that this angle over here is the same as that angle that I already have marked? Yes? Okay, so if I put in here that this is 56.3 degrees, this angle here, that's not this location right here, this dot on the unit circle. How do I figure out that location in degrees if I start here at 0? How far is it from here all the way around to here? How much is it? 236.3 degrees. How did I get that? I took the 180 degrees and I added 56.3 to it. Half a revolution plus the little bit extra. So there are two solutions to this, but you have to be able to think it out and connect the dots because of the limitations of inverses. All right, let me erase this.